Okay, Assalamualaikum. So today we focus on chapter 5, which is the comparison of several multivariate population mean. But in your textbook, it is on chapter 6, page 273. Okay. From previous chapter 4, you have learned about how to know whether a certain mean vector is a plausible value for the population mean, right? Multivariate population mean untuk satu population. But now, in chapter 5, we can see whether the several multivariate population mean, let's say we have two population, we can compare the population mean of the multivariate is differ among first population with the second population, or first population with the third population, and so on. Okay, in the context of multivariate. Okay, so mostly the assumption for this chapter, we will use the assumption of multivariate normal distribution, or we are using the large sample size. We also can review the univariate procedure for comparing several means that you have learned before this in maybe dalam step method untuk univariate, and we will generalize to the corresponding multivariate cases by analogy. From the concept of univariate procedure, we will use again in the multivariate cases by analogy. Kita akan tengok balik lah. Alright. Okay. So, the first topic adalah comparing the mean vector from two population. Untuk dua population sahaja. Okay, after this we can see if we have more than two population. Okay, so if we have two population, kita tengok dulu dia punya descriptifnya. Let's say we consider a random sample size small n1 from first population and small n2 for the second population. Okay, we have two population with the sample size is small n1 and small n2. So the observation on p variables can be arranged as follows. Okay, let's say here population pertama, the first population, we will have x11 until x1n1, which mean the subscript for the first of subscript tu adalah denotes the population. This first subscript 1 refer kepada first population, another 1 tu yang belakang tu refer kepada observation pertama, sehinggalah variable untuk first population and one observation. Okay, yang kedua for the second population, it will be x21 until x2 and 2. Ini adalah notation untuk variable. So we have the several variable for population 1 and population 2. Then we shall find the sample mean x1 bar and sample mean x2 bar. Okay, and we also will have the sample variance S1 and sample variance S2 for the population first and second population. Okay, kena buat satu-satu lah untuk first population and second population, and then macam biasa kena cari mean vector dan juga variance covariance. Okay, so our intention adalah to make the inference about the two mean vector. Okay, our intention kat sini kita nak tengok whether both of the two population ni differ or equal. macam yang you belajar dalam step method, kan? So how we can do that? Kita tengok the difference between first mean and the second mean. Cuma bezanya dalam multivariate ni kita akan ada vector. Sebab dalam first population dan second population kita akan ada beberapa variable, multivariate. Okay, so sebab itulah kat sini dia bold. mu1 minus mu2. We want to make the inference, the difference between mu1 and mu2, which is the mean vector for the population 1 minus mean vector for the population 2. Okay, equivalent juga if we will do this. mu1 minus mu2 equal to 0, which is we want to see whether the components of mean are equal ataupun not differ or differ. Right? Okay, let's see the assumption concerning the structure of the data. Okay, as you know, kalau multivariate, we will deal dengan vector ataupun matrices. So we will bold the X here. So X11, X12 until X1n will be the random sample for P variate population with mean vector mu1 and covariance matrix big sigma 1. So mean vector mu1 ni refer kepada population 1, mean vector untuk population 1, tapi dia akan ada mean vector, dia akan ada beberapa lah, depends pada you punya variable, p variable. So maybe it will be the mean vector, it will be p by 1 lah, mu tu kan. Kita akan tengok how many variable yang ada. So mu1, vector mu1 and vector mu2, dia punya bilangan x bar tu tak sama lah. It depends pada how many variable that involved in population 1 and population 2. But biasanya kita akan compare dengan variable yang sama. Okay. Covariance matrix sigma 1, big sigma 1, covariance matrix for the second population sigma, big sigma 2. Okay. And then X11 until X1n1 adalah independent kepada X21 sehingga X2n1. Ini dia punya assumption. Okay, so you kena tahulah dia punya notation mu1 tu apa, big sigma 1 tu apa. Okay, and then for the assumption, we have to know the further assumption when we are dealing with the small sample size. N1 and N2 are small sample size. So kena ada lagi further assumption. Kalau you punya sample size is large, tak perlulah nak take account this assumption. So it should be bila N1 and N2 are small, both population mesti multivariate normal. Okay, untuk kita nak gunakan the method. And then the covariance matrix will be same. Sigma 1, big sigma 1 and big sigma 2 is equal. It will have the common covariance. Kejap lagi ketika kita tengok, kita akan denote-nya sebagai big sigma sahaja because of big sigma 1 and big sigma 2 are equal. Okay, let's see. Okay, here when big sigma 1 and big sigma 2 are equal ataupun dipanggil common variance. Okay, so this part kalau you tengok dalam your textbook ada dekat page 285. Okay, this is the way how we find the S-pool untuk kita nak estimate the big sigma tadi. Okay, kita akan kira, we estimate the big sigma using the S pool. So from this to theory that we know, we can produce this S pool. Okay, further explanation ada dekat page 285. But for your level sekarang ni multivariate, kita punya topik ataupun syllabus, tak perlu you nak hafal cara nak dapatkan S pool, cuma you need to know ataupun you need to hafal the formula of S pool, which is the estimator untuk big sigma, which is small n1 minus 1 divide n1 plus n2 minus 2 multiply dengan S1. Okay, S1 adalah the variance covariance metric for the first population, and S2 adalah variance covariance metric ataupun sample variance covariance metric untuk second population that we have estimate sebelum tu. Okay, alright. Tadi kan nak estimate mu 1, kita gunakan x1 bar and x2 bar. Okay, nak estimate the big sigma, kita gunakan S pool, because we consider that big sigma 1 and big sigma 2 equal to big sigma. We have the common covariance. Okay, let's see the method. Dia punya step sama. First of all, kena ada hypothesis, and then kena ada test statistik, and then kena buat decision. Okay, and then conclusion. Okay, so kita punya intention to test the hypothesis of mu1, mean for the first population, and mean for the second population equal to delta naught. Delta naught ni adalah notation untuk the difference between the two mean vector. Tapi biasanya kalau kita just nak tengok whether the first population and the second population is differ or not, so delta naught ni kita letak sebagai zero vector lah. Okay, so to make the test statistic, first of all we need to know this assumption. Okay, expected value of x1 bar minus x2 bar adalah mu1 minus mu2 vector of mu1 minus vector of mu2. And then the assumption tadi, bila n small, ataupun the assumption concerning the structure of the data from the previous, dikatakan mean vector of x11 until x1n1 are independent with the vector x21 until x2n2 because of x1, and then we also can say that x1 bar and x2 bar are independent, and then because of that the covariance of these two main vector will be 0. So sebab itulah covariance kat sini will be 0. So we will have, last kali untuk dapatkan covariance of x1 bar minus x2 bar will be covariance of x1 bar plus covariance of x2 bar. Okay, and also we know that from the previous chapter, the covariance of mean vector adalah big sigma divided by n. Betul tak? So because of here big sigma divide dengan n1, here big sigma 2 divide dengan n2, and then we have the common big sigma 1 and big sigma 2. So dia akan jadi sigma, sepatutnya kat sini, sigma 1 over N1 plus sigma 2 over N2. Ini from the theorem from the previous chapter, maybe chapter 3 before this. Okay, so because of big sigma 1 and big sigma 2 is common, so kita denote sebagai as sigma saja. So because of that, sigma over N1 plus big sigma over N2. So because of that, this is the formula untuk nak cari covariance between x1 bar minus x2 bar. Okay, so we estimate the big sigma here dengan S pool tadi, the formula tadi yang kita create. So means that to estimate the covariance of x1 bar minus x2 bar will be x over n1 plus 1 over n1 plus 1 over n2 multiply dengan S pool. S pool you need to memorize tadi formula before this. Okay, let's see the results of 6.2 from your textbook dekat page 286. Okay, this is the way how we create the test statistic t-square sebenarnya. Okay, yang ni I cakap tadi tu. If x11 until x1n1 adalah normal with mean vector mu1 dan sepatutnya kat sini big sigma 1 kan, sebab tapi because of assumptionnya adalah the big sigma is common covariance, so dia akan jadi big sigma sajalah kat situ. Okay, so the t-square adalah, kan sebelum ni kan x bar minus mu kat situ kan, x bar minus mu transpose multiply the inverse of S multiply x bar minus mu. So kita gunakan konsep yang sama. Because of this kita akan gunakan distribution of x1 bar minus x2 bar. So kat sini akan jadi x1 bar minus x2 bar, so minus its mean which is mu1 minus mu2, and then multiply dengan inverse of the, kat sini variance covariance matrix, so kita gantikan dengan estimation of the big sigma tadi, here and then here. So this t square will be distributed as f distribution. Okay, yang ni c square yang you dah hafal sebelum ni, so sama juga, so you kena hafal this one. Okay, this c square. Okay, so we will use this untuk nak buat the decision rule nanti. Okay, this is the test statistic t square. Okay, so we see the method here. The hypothesis will be mean vector mu1 minus mean vector mu2. Sepatutnya mu kat sini will be bold lah kan, sebab mean vector mu1 minus mean vector mu2. Bila sebut vector, dia akan jadi, so maksudnya mu1 ni, vector mu1 will be p by 1 and vector mu2 will be also p by 1. And then dia punya dimension sepatutnya sama lah. And then equal to delta naught dekat sini. Kalau kita nak tengok difference between mu first population, mean for the first population and second population, delta naught kat situ akan jadi 0 vector. Okay, this is the t square tadi, the t square, and we compare with c square. Okay, this is the formula. Okay, we will reject hash naught if the value of t square more than the value of c square. Okay, bila reject hash naught, apa kita akan conclude macam mana? If the hash naught is rejected, we can say that the mean for the first population and the second population are differ. Betul? Ataupun kalau you ada the population ada nama dia, and then the variable pada nama dia, you can put the name of the variable and the name of the population in your conclusion. Let's see the example. Okay, example 6.3. Dalam your textbook, ada dekat page 287, we have this example from 6.3. Tapi dalam your textbook, dia gunakan method yang berbeza. Dia gunakan method ellipsoid. Boleh juga sebenarnya. Ataupun kita gunakan method hypothesis testing. Dua-dua pun boleh sebenarnya. Satu lagi adalah gunakan confidence interval. So, ada 3 cara lah sebenarnya nak tengok whether the mean of the two population are differ or not. Okay, gunakan hypothesis testing ataupun gunakan ellipsoid, region of ellipsoid, ataupun gunakan simultaneous confidence interval. Okay, let's see macam mana nak gunakan hypothesis test. Okay, information from example 6.3 saying that 50 bars of soap are manufactured in each two ways. Two characteristics, whether leather or minus are measured and minus are measured. Okay, so maksudnya kat sini we have two population, which is two method tu adalah dua population lah, first method and second method. Two characteristic, whether it is leather and minus tu adalah your variable. Okay, so given the information here, we can say that the sample size is equal 50 and x1 bar here adalah x bar untuk first population untuk method pertama, dan x2 bar kat sini adalah mean untuk the second method. Kat sini value 8.3 here adalah mean untuk first variable, which is leather for the first method. This one 10.2 adalah mean first characteristic ataupun first variable x1, okay, untuk second population. 4.1 adalah mean untuk mildness for the first population. 3.9 mean untuk mildness for the second method, which is the second population. So dekat sini, and then di sini S1 dan S2 here adalah variance covariance untuk first population and variance covariance untuk second population. So 2 kat sini, 2 here adalah the variance for the variable leather for first population. 2 here, variance for the first population, variance for the first variable of second population. Faham tak? Kena faham betul-betul apa dia punya notation tu. Takut tertukar because of we have two methods and two characteristic. We have two population and two variable here. Okay, so in order to find the t-square, we need to find the variance covariance. Kita nak estimate the big sigma tadi untuk x1 untuk mu1 minus mu2. Okay, estimate the sigma. Expo ni estimate the big sigma of distribution x1 bar minus x2 bar. So ini dia punya variance covariance matrix. So we get this value, and then x bar 1 bar minus x2 bar is this. Okay. So we started the hypothesis testing. Find the value of t-square. Since we have all the value tadi, dah ada x1 bar minus x2 bar and so on from this here tadi. So we can calculate the value of t-square. Delta here and here will be 0 because of kita nak tengok delta here and delta here is 0. because of we want to see whether there is a difference between the two population of the multivariate population. Okay, so we have the t square here, and then make the decision rule. So you need to find the value of c square to compare with t square. So since t square is 52.47, and nanti check dia punya F distribution, the value is 6.244. So because of 52.47 more than the c square 6.244, so we reject hash not. So what can we conclude from this rejection of hash not? We can say that the two methods of manufacturing soup produce different results. Okay, because of two methods are differ, so it will give the different results. Okay, we move to the confidence interval. As I said before this, we also can use the confidence interval to make conclusion about the mean difference between the two population. Okay, cuma using the hypothesis testing, we can make conclusion whether the mean vector of the two population differ or equal, right? Okay, kita boleh make conclusion straight away, but using the confidence interval, because of we have several variable, so we need to see the confidence interval for each variable. Then if each of the variable having ataupun concludes that the two population are differ, barulah we can conclude that actually the two population are differ, the characteristic of the two population are differ. Okay, let's see the formula. Kita gunakan konsep yang sama macam sebelum ni. So because of we want to find the confidence interval for mu 1 and mu 2, first mean of first population and second population, it will be mean vector first population minus mean vector second population plus minus c here adalah kita gunakan F distribution from the previous topik sebelum ni. You know how to find the c square here, but now kita letak c, multiply the variance covariance, and no, actually multiply the variance for each variable. Okay, so as I said before this, we find the confidence interval for each variable. So here mu 1i minus mu 2i, I tu adalah refer kepada variable. Let's say we have two population, we have two variable, so we need to find the confidence interval for both first variable and second variable. So it will be mu 11 minus mu 21 for the first variable, and then kena cari satu lagi confidence interval for mu 12 minus mu 22, means that kita cari confidence interval for second variable. Okay, alright, so this is the formula. Okay, let's see the example. Example ni actually example 6.4 in your textbook, page 289. Okay, calculate the simultaneous confidence interval for the differences in mean component of two population. Okay, let's say sample size for the first population is 45, the second population is 55, were taken of Wisconsin homeowners with and without air conditioning. So maksudnya kita ada dua population, homeowners with air conditioning and homeowners without air conditioning. To measurement of electrical usage, measurement kita electrical usage were considered. The first is a measure of total on-peak consumption. The electrical usage on peak consumption will be the X1, and the electrical usage for the off-peak consumption will be X2. So we have two variable. We have two population and we have two variable. So kita punya variable adalah electrical usage on total peak and electrical usage on total on peak and total off peak. Okay. Alright, so the information given here, dia bagi you X1 bar, X2 bar, as I mentioned before this. 204.4 ni adalah refer kepada mean for the mean of electrical usage of on-peak consumption, which is X1 for first variable. 556.6 adalah mean of electrical usage of off-peak consumption for first population. 130 is the electrical usage of on-peak consumption for second population. 355 adalah electrical usage ataupun mean electrical usage of peak consumption for second population. Okay, so ini adalah variance covariance for the first population and second population. So here adalah variance for the first variable, variance for the second variable, okay, of first population. Here variance for first variable for second population, variance for second variable for second population. Okay. Alright, so in order to find the confidence interval for each of the variable, we need to find the S-pool. Okay, using the formula before this, and then you can find the C squared. So with all this information, we just apply the formula of confidence interval about the population mean difference. Okay, so tengok kat sini, here on peak, here off peak, means that we find the confidence interval for the mean different population mean difference. We find the confidence interval for the population mean difference for every variable. Okay, for the first variable, we use the information sebelum ni. 204.2 minus 130 means that 204 adalah mean untuk first variable for first population. 130 mean untuk first variable for second population. Okay, sebab kita nak tengok untuk first variable on peak, the electrical usage on peak consumption. Okay, we use the information given here, and then here 109.63 we get from here. Okay, untuk first variable, and then apply the same thing for the second variable. Okay, so last kali, the result that you get, the mean difference for first variable will be 21.7, will be in the range of 21.7 and 127.1. So it seems that these two interval does not include 0. So we can say that the mean difference are significant. The mean difference of the two population are significant for first variable. Okay. Tengok pula untuk second variable pun sama. the interval does not include 0. Okay, so both of the confidence interval for each of the variable does not include 0. So what can we conclude for overall? There is a difference in electrical consumption between those with air conditioning and those without. Maksudnya ini adalah population kita. Population kita tadi kan adalah homeowners with air conditioning and without air conditioning. So we can say that the difference in electrical consumption between those in first population and second population are differ. The difference is evident in both on peak and off peak. Kalau both of the confidence interval adalah differ, we conclude as differ. So for overall, baru kita boleh katakan there is a difference in the mean electrical consumption between the first population and the second population. Okay, if we are using the confidence interval. Alright. Okay, the next one adalah confidence interval untuk Bonferroni. Macam sebelum ni, previous chapter pun, I have mentioned there is two formula to find the confidence interval, whether gunakan t-square interval ataupun Bonferroni kan. So, sama juga kat sini kita ada dua formula, Bonferroni dan juga simultaneous confidence interval gunakan cara biasa tadi. Okey, apa beza antara Bonferroni dan yang sebelum ni for this one? Okay, Bonferroni will give the result of the confidence interval that is more narrow. Okay, narrower or smaller confidence interval. It tends to have the more precise result. So actually kita biasanya usually we will use the Bonferroni simultaneous confidence interval. Apa bezanya? Kalau you tengok formula dia sama je dekat sini, sama dekat sini, cuma bezanya dekat distribution. Sebelum ni kita gunakan F, kan C tadi, C square kita gunakan F, but here kita gunakan T distribution. Okay, so nanti you try buat using the same example, but you use the Bonferroni confidence interval and you can see dia punya beza lah, dia punya range of the confidence interval. Bonferroni is narrower. Okay, how about tadi kita cerita tadi kan gunakan test statistik dan juga gunakan confidence interval untuk small sample size dan common covariance, betul? Okay, so let's see pula how if the two sample situation when big sigma 1 not equal to big sigma 2, maksudnya we don't have the common covariance. So if this case happen, we cannot use the previous formula. Okay, let's see. If this happen, we unable to find the value of t square. So we will use the concept of ataupun we will change daripada F distribution kepada chi-square distribution, but if and only if it involve large sample size. Okay, let's say if n1 minus p and n2 minus p are large, so we will use this formula to calculate the confidence interval ataupun to make the decision about the difference between two mean. Okay, kita akan gunakan theorem, which is we use the chi-square p. Okay, this theorem that you have learned in chapter 3 before this. Okay, so simultaneous confidence interval for mu1 min vector 1 minus min vector 2, maksudnya min vector for first population and min vector for second population will be this formula. Bezanya dekat sini, tadi kita gunakan sama ada C, which is F distribution, ataupun T distribution. Now kita tukar kepada chi-square distribution. And then beza dekat sini, when you want to find the variance. Okay, when we want to find the variance, kita gunakan this formula. Okay. Kalau small sample size, because of we deal with the large sample size. Kalau small sample size tadi, kita akan gunakan S pool, and because of the variance, covariance have the common covariance, kan, for the first population and second population. Okay, but if a large sample size for the first population and second population is equal, kita guna balik formula S pool. Kenapa? Actually, daripada sini. Nanti you boleh try derive. But in exam, no need for you to derive of this. Just you need to know saja. Tapi kalau nak guna formula yang sama pun tak ada masalah. Okay, let's see the example untuk large sample. Okay, let's say kita gunakan example yang sama tadi, which is the electrical consumption for the homeowners with air conditioning and without air conditioning. We have the information about the min vector and also the variance covariance metric for each of the population. Okay, so in order to use the large sample approach, we need to find the new variance covariance ataupun estimate of the big sigma. Okay, we have this. Nanti boleh check. Okay, so sama dia punya method. We use the same approach, which is we need to find the confidence interval of the mean difference of the population for both of the variable, because we have two variable tadi kan, x1 and x2. So this one sama. Here kita gantikan dengan chi-square distribution. Degree of freedom is 2 because of P is 2. And here adalah standard deviation for the first variable, which is we take from here. Okay, di sini. Here we take from this matrix. So lastly, you will get these two confidence interval. Seems that both of the confidence interval does not include 0, so we can make the same conclusion as before this lah. Okay, you can interpret the confidence interval for each of the variable. Okay, and then last kali make the conclusion about the overall of the mean difference of two population. Okay, how about macam tadi kan kita deal dengan small sample size. I dah tunjuk macam mana nak gunakan hypothesis method dan juga confidence interval method to make the conclusion about the difference, mean difference of two population. So this one pula adalah confidence interval bila kita deal dengan large sample size. which is we replace the T or the C with the chi-square distribution. Okay, how about if we want to doing the hypothesis testing? Dia punya hypothesis sama macam sebelum ni. Cara nak cari T-square actually gunakan approach yang sama, cuma bezanya di sini S ni kita tukar kepada this formula because of we deal with the large sample size. Okay, and then kita comparekan nilai T-square here dengan chi-square P. Okay, so you akan dapat kat sini T-square more than the value of chi-square 2, which is 5.99. Therefore, we reject H0. So, we can make the conclusion that sama macam tadi jugalah. We can make the conclusion that the electric consumption the mean electric consumption for both population, which is with or without the air conditioning, are differ. Ataupun you can say that the mean difference of electrical consumption for homeowners with air conditioning and without conditioning are significantly differ. Okay, itu sahaja